Bismillahirrahmanirrahim. Assalamu alaikum and hello to everyone. Today I have made this video to show you how to make a unique method of making a automatic turn on and off submersible pump or water pump with the level of the water as I have shown in this tank or in this diagram. So guys, you can see this is the positive wire. I hope you can see it, and it is connected with the positive terminal of these a couple of relays. Let me tell you, these relays are based on 220 volts as I have shown you and written in down here, and the minimum amperes which I have got or which I have bought from the market is 15 amps. So guys, these relays are based on 220 volts. The coil of these relays are 220, so you can see I have connected the positive 220 with this terminal and as well as connected with this terminal, and another jumper I have used with the switch of this relay. So another wire is negative. You can see this negative wire is directly going on with connected with the submersible pump, and another wire is connected with this negative wire which is connected with this relay. This relay is based on 220 volt as well, and the amperage of this relay is very high rather than these relays. You can see 120 amperes, and another wire I want to show you another jumper or another junction of positive one, and which is connected with here, and it is going on here and connected with the switch of this relay. Why we have used a heavy relay? Because the submersible pump has the very high power or very high amperage to turn on. So if we directly connect it with these relays are not very powerful or not very durable to afford the load of the submersible pump. That's why we have used 120 relay, and this relay will provide positive volt to this relay, and it will turn on, and positive volts will be get in and get out from here by the switching of this relay. And this relay is 120 ampere, and it is a very heavy relay. So the function of this diagram, I hope you can see it. The function of this diagram, you can see, I want to show you. It's quite difficult to describe this diagram, but I will try my level best to teach you as well as I can. So this relay, you can see a negative terminal is connected with the top level of this tank. When the water will touch it, so the negative volts which are traveling by this negative wire, you can see this is another jumper, and this negative wire is connected with the minimum level of water. So the water can carry the negative volt or AC volt rather than DC. That's why I have tell you that you cannot use DC relays. DC volts cannot turn on the relay, but the AC relays can be turned on by the negative volts which are going on with the water, and it will touch this level, and the relay will be on. The relay will be on, and this switch will be turned off, and the motor pump will be turned off. So question is that when the water is get down or decrease or disconnected with this terminal or this wire, it will again turn on. This is why people do not like these circuits. But if in this circuit you will see the water will touch this level and the motor will be turned off, and when the water will disconnect it with this wire, and it will not turn on until the water will disconnected with this level of wire. So how is it work? You can see when the water level is get down and the motor will not turn on. Why? Because this wire is connected with the water. If the water will disconnect it from here, then the motor will be turned on and will not be turned off by touching this wire. Again, it will touch this highest level of wire and it will be turned off. So guys, you can see this is the top level of this water tank, and when the water touch to this level, and it will carry the negative volts, and negative volt similarly goes down and connected with this terminal, and this terminal is connected with this terminal, and this jumper is connected with this terminal. So positive is available, negative is available because of this level, and when the water go down disconnected with this terminal, so this negative wire will shift the negative volts from here to here, and it will be connected with the minimum level, as you can see. When the water level decrease and disconnected or separated from this wire, it will turn on the motor. When the motor is turned on, the water level again touch this wire, it will not turn off the motor, because when the water get down or get disconnected by this wire, so the negative volts disconnected this terminal, and this terminal will be, this wire is disconnected, so this connection will be turned off here. So the relay will be turned off. If the relay is turned off, this connection will shift to here, and motor will not turn on. So guys, you can see this is the top level of this water tank, and when the water touch to this level, and it will carry the negative volts, and negative volts similarly goes down and connected with this terminal, and this terminal, these wires are dependent with each other. If the water level will separated from by this level, so the function of this wire will be shifted to this, and if the water will touch again to this level of highest level of water tank, and the function of this level will be shifted to this. That's why this cycle is going up and down like this, and the motor will turn on and off with the water level of these two wires. It will not turn on and off again and again, and it will work very properly. So this is the whole demonstration, and I will show you the practical work as well, and so keep in touch with me. So guys, this is the practical demonstration, and I hope you can understand the whole process. And now let me show you the DC relay. This is called DC relay 12 volt, and the coil is working on 12 volt DC. So I have fixed the continuity of this relay with this meter. So guys, you can see on this digital meter there are 12 volts available on this power supply. So guys, you can see on this digital meter, let me connect the relay with this 12 volt. Let me connect the when we turn on the relay, the continuity will be shifted on other side, as you know the function of the relay. So now let me go further, and as I have told you that the DC relay cannot work in the water. I don't know the exact reason, but I think the AC relay can work with the water, because the AC volts travel more frequently rather than DC relay, DC voltage. So that's why DC relay are not successful in these projects. So let me show you the AC relay. Now you can see this is the AC relay. These two terminals are for AC connection or coil connection. If you connect the wires with these two terminals, 220 volts. These 4 connections are working with each other, on and off switching system. That's the function of the relay. So let me fix the wires and let me pause it for a while. So guys, you can see, you can assume this water like a tank. So let me dip it in the water to show you whether is it working or the voltage are traveling in the DC volt traveling in the water or not. So you can see there is no continuity or there is no clicking sound in this relay. So that's why I told you in my last theoretical video said that you should not use the DC volt relay because the DC volts do not travel, or DC relay wants direct connection to turn on. And let me again touch it to show you that this is the real video. Now let me fix the AC relay and I will show you the demonstration of AC relay. So let me pause it again. So I connect these both wires and the relay click you can hear, I think, and the continuity is shown on the analog meter on this. So let me dip it in the water and I will show you how is it working. Now you can see this AC relay is working in the water. So that's why this project is based on AC relay. So I hope you would understand my theoretical and practical way of demonstration. So guys, you can see if I connect these both wires with each other, this bulb which is 100 watts, so it will glow. So now you can see I will short it or I will connect it with each other. You can see this is 220 AC relay function. Now let me dip it in the water and you will see how does it work. Now you have seen. That's why I make this project with the AC relay, and don't worry about the shock of water tank because the positive volts will not travel in the water because of the negative or the ground wire. This is my practical final demonstration, and in this project you can see how on-off automatic circuit work with the water tank and the level of the water. And you can see these 3 wires. This is orange one, this is brown one, and this is white one. So you can see the white is connected with the bottom, which carries the negative or ground volts. To travel the ground volts or negative volts, first of all to this, and then it will shift to this brown wire. This is the orange wire, this is the brown wire. This is the top level where the motor will be turned off, and this is the level where the motor will again turn on. So let me start the demonstration. So guys, this is another way of demonstration. So you can see the load, you can assume it, this bulb is a water pump or submarine pump, and it is on now. And when you can see the orange wire touch the water, it will not turn off. And when it will when it will touch the brown wire, this one, then it will be turned off. So you can see this is the whole demonstration. Now if I disconnect or separate the brown wire from the water, the motor will not turn on. And when I will separate the orange wire from the water, then motor will be turned on to fill the water. Now you can see, and again if the water touch again this orange wire, it will not turn off the motor until it is touch the top level of this brown wire, like this. You can see this is the whole demonstration. So bye bye for now.